Hello everyone, welcome to Pratibha Tech. In the previous video, we saw an overview on Java 17. In this video, we will look at different features provided in Java 17. So let's get started. New features in Java 17. JDK enhancement proposals or the JPEs are provided as below. JEP 306 restore always strict floating point semantic. 356 enhance pseudo number generators. 382 New macOS rendering pipelines. 391 macOS architecture 64 port. 398 Deprecate the applet API for removal. 403 Strongly encapsulated JDK internals. 406 Pattern matching for switch. It's the preview version. 407 Removal RMI activation. 409 Sealed classes. 410 Removal experimental AOT and JIT compiler. 411 Deprecate the security manager for removal. 412 Foreign function and memory API incubator. 414 Vector API second incubator. 415 Context specific deserialization filters. Going forward in this video and in the series, we will be looking at all the JPEs in detail. If you look at all the JPEs from the developer's perspective, then we can see very few major updates have been added because Java is on 6-month release cycle. All the JPEs can be broadly classified in 4 categories. First category, nice developer related features. Under this category, JEP 406 pattern matching for switch and 409 sealed classes are placed. Second category, developer specific features. Restore always strict floating point semantics. Enhanced pseudo random number generators. Strongly encapsulated JDK internals. Foreign function and memory API. Vector API and context specific deserialization filter. Under category 3, keeping up with Apple kind of stuff. New macOS rendering pipelines and macOS architecture 64 port. Under category 4, cleaning up kind of stuff are placed, like deprecate the applet API for removal, removal RMI activation, removal experimental AOT and JIT compiler, deprecate the security manager for removal. In this video, we will look at the first feature that is provided in Java 17 in detail, that is restore always floating point semantic. With JEP 306, Java changes some of the floating point semantics. The goal of this change is to add regularities to floating point operations by making them always strict. Before Java 1.2, this was the default behavior, but this required lots of overhead on some of the hardware architecture. A strict FP is a modifier or keyword that stands for strict floating point, was introduced in Java version 1.2. It is used in Java for restricting floating point calculation and ensuring the same results on every platform while performing operations in a floating point variables. Floating point calculations are platform dependent, that is, different output is achieved when a class file is run on different platforms, that is, whether 16-bit, 32-bit or 64 bits of processor. To solve this type of issue, strict FP keyword was introduced in JDK 1.2 version by following IEEE 754 standards for floating point calculations. After Java 1.2, without using strict FP keyword, the floating point precision depends on target platform's hardware, that is CPU's floating point processing capabilities. However, now the processors have advanced and these operations do not require a lot of overhead. These strict floating point operations are now supported. So now no additional mode is required. In fact, by making floating point semantics always strict, it provides more consistency in working with floating point numbers and eases the development of numerical APIs. To understand it better, let's move to IntelliJ. Here in this method, we can see the keyword strict FP is used. If you are not using this keyword strict FP, then the output will depend on the machine where the class file is being run. Whether it is a 64-bit, 32-bit or 64-bit of operating system or the processor. But once we add strict FP in this one before Java 17, then this was ensured that the result will be consistent in all the platforms. But with Java 17, we can see here it is giving a kind of warning saying modifier strict FP is redundant on Java 17 and later. So that's all in this video. Stay tuned for the upcoming video. If you like the video, please subscribe the channel. Thank you.